Esta conferencia comenzará a grabarse.
Hello, Alan and the TADHack community. Here we are from PAiC Business Development for TADHack Global 2021. This is Fernando here, and I am with my colleagues Emmanuel Calero, Kenny Mendieta, and Darman Perez. I'm here in Uruguay. Berman, Kenny, and Emmanuel are from Nicaragua. And we are going to start with our presentation on our hack for TADHack Global 2021. Okay, a little word from us. We're a company that has global presence. As said, here are representatives from Uruguay and Nicaragua, but we have people in El Salvador, in Panama, in Honduras, in the United Kingdom, in Mexico, in India, Israel, in Tanzania, in Spain, also in Ghana, and in the United States. Okay, we do software for telecommunications, software for commerce solutions, and for business solutions for enterprises. Okay, we are going to obviously give away this presentation for TADHack, so you can check a little brief of our products. As this has been shared over the TAD Summit 2020 back in November, so you can go there for more details. But the goal of this presentation, obviously, is TADHack Global 2021. So here we have our footprint, the people that are now integrated in our company. As you can see here, we have people from all over the world following the sun. As said, I am from Uruguay. We have Emmanuel, Kenny, and Berman from Nicaragua, but as you can see, we have people in all the continents. Okay, so let's go to the TADHack Global 2021 hack from us. We are going to focus and do a mashup of our geolocation ecosystem with the API from TELNYX, the SMS API from TELNYX. Firstly, we are going to talk about our geolocation solution, which has highlights a global functionality. So with this we mean that it's independent of core or radio access network, device hardware or software. It's operational in low-grade network conditions, such as underground or indoor environments. It provides an API, a cloud-based API that allows service providers to integrate universal location data to any IoT applications, triggering actions and responses from other networked devices and communication channels such as voice and messaging. The geolocation provides mobile location information that can be retrieved autonomously or triggered by asynchronous events from messaging services such as SMS or USSD, also voice or any means, independently of the underlying network infrastructure. And we support geofencing or sonic alerts, so we can receive alerts upon entry or exit or staying in track devices in predefined zones, as well as receiving alerts when devices approach zones within a predefined distance. Okay, so this hack we are going to present now is, as said before, identical almost to the one we showcased at TAD Summit 2020 back in November, but we are integrating now the TELNYX SMS API. So I'm going to give the voice and the screen to my colleague Emmanuel to talk us about the TELNYX SMS API, as he was the guy in charge of studying it along with Kenny. And please, Emmanuel, your time to shine.
Hello, TADHack. You can see my screen right now. Let me check. Okay. Yes, you can see my screen now.
Yes, we can. Go
Okay.
ahead.
Yes.
Yeah.
Okay. Why do you use TELNYX? It's simple. Its communication API make things easier. Our solution, as Fernando said, requires sending text message in anywhere in the world. With TELNYX, we can make it possible. So using the SMS API that is very simple and quickly to integrate with our products, using the documentation, there is a good documentation, and the SDK. The SDK with Java is simple. And now you can see another thing important is that we have the reports. So I'm gonna show you reports that all the tests we are using was this. That this was all the tests that we are using, and this is very important to us because we can do a report to our customers. Now we can continue with the presentation, Fernando.
Sure, thank you, Emmanuel. Okay, so let me continue. Okay, so what we're going to show you, and as I said, this is almost identical to the demo we did for TED Summit 2020 back in November, but integrating the TELNYX API. So basically, it's a USSD trigger location-based emergency service with geofencing. And what we're going to see is a user dialing *911 * a contact number hash, and that is a USSD shortcode with a parameter, which is the contact number that is the number that is going to be used for sending the SMS to TELNYX. And this USSD session will reach PAiC's extended USSD gateway. Then the extended USSD gateway will contact the extended service delivery platform of PAiC according to its routing rules. Okay, so at that moment, the extended SDP will contact the Geolocation API, PAiC's Geolocation API, to perform a MAP ATI anytime interrogation via to the HLR of the network via the extended GMLC, another of our platforms, of our core network platforms. And this is according to the logic of the project created in the extended service delivery platform via its service creation environment. So once the Geolocation API gathers the location information from the GMLC and actually from the and directly from the HLR, it performs another location request to the extended GMLC, which will be a more sophisticated one, and this will be through Diameter SLh-SLg reference points in order to arm the geofence to request a location report from the LTE Radio Access Network, while the requested MSISDN of the USSD requester exits the area given by the LTE Cell Global Identification provided initially by the MAP ATI. And at that moment, the extended SDP will send an SMS through the TELNYX API to the contact number with the current location of the USSD requester user demanding assistance. Okay, and finally, the SDP will order the USSD gateway to end the USSD session, informing the current location and the delivery of the SMS to the desired contact number to the USSD request. Let's see now at the code flow. This is how it looked in the TAD Summit demo we did back in November 2020. But in this well, here you can see at the left the radio access network, the core network of the operator, and the core elements of the geolocation ecosystem of PAiC, which are the extended USSD Gateway, the extended GMLC, the extended SMSC, the extended STP with the Geolocation API, and the extended Geo, which is a platform where we have as a kind of a front end of the extended GMLC, and where many location-based services applications reside. Okay, but in this case, we're going to integrate TELNYX, and we're going to replace our extended SMSC for the TELNYX API, as TELNYX is one of the sponsors of TADHack Global 2021. Okay, so initially the requester is sending or starting a USSD session, which will reach the extended USSD gateway by dialing *911* the contact number hash, and the extended USSD gateway will contact through USSD over SIP the extended STP, and then trigger a HTTP post to the extended GMLC to send a MAP ATI to the HLR. Okay, so once the extended GMLC gets the information from the HLR, it sends back through HTTP to the extended STP in JSON format, which will then trigger the diameter location request to the LTE network in a more sophisticated way, because by this diameter commands, we are asking the network to do a triangulation and to get together the geographical coordinates of the user equipment of the USSD requester. Okay, so once we get the provide location answer from the MME, the extended GMLC will deliver the location information to the extended STP, and the extended STP will send the location information to Geo. So this platform can show in a Google map where the USSD requester is at, and of course later there can be a tracking of this user, and further reports and information of the user. Following, we are sending the SMS to TELNYX. Okay, and the SMS is going to be to the number of the contact number that was delivered by the USSD requester. So TELNYX will send the SMS to that number, and then we will get the answer back from TELNYX. Upon that, the extended STP, the service delivery platform, will order the extended USSD gateway to end the USSD session, and therefore the USSD requester shall get the response, which will contain the location information at which it is standing, and also a text that says that the SMS has been delivered to the contact number. Upon a geofence event, in this case, if the USSD requester exits the zone defined by the Cell Global Identification of the initial MAP ATI, the radio access network will send a report which will be delivered through Diameter to the extended GMLC, and the report will be sent to extended Geo for showing it in a map. So this is it. Now Berman is going to show us what we just showcased here, but in the real life with our USD phone simulator and his cell phone that is going to receive the SMS from the TELNYX API. So Berman, now it's your time to shine.
Okay, I'm going to share my screen. Can you see my screen now?
Yes.
Okay, this is our USSD simulator. USSD simulator, I'm sorry. We're going to run the test. 911 is the USSD code that we defined for this test. And this is my phone number, the destination number where we are going to send this request. Up here we can see the originator number. Okay, go ahead. Okay, this is the successful response. Now I'm going to quickly change my screen to my cell phone to show the message. I'm presenting my cell phone screen right now.
Yes, we can see it. That we have the message.
Yes.
Let's try
right.
a couple more tests.
Sure.
Now Berman is running some more simulated tests with a USD phone simulator, and is, as you can see, the first one is telling that this number is located at this latitude and longitude, okay, and is requesting your assistance, okay. Now we have another one. This goes to a simulator, okay, simulating the SS7 and the Diameter network. So we are getting different locations at each test. Okay, so Berman is getting different.
I'm sending a third right now.
Different cell IDs and different latitudes and longitude, but always the requester is the same. Okay, so yes. Great. This is the test. So this SMS was sent through the TELNYX API using our geolocation ecosystem platforms. Okay, so maybe now what we can see is in the extended geo, the results where we are going to see the locations gathered in a map.
Okay. Okay. I'm just to quickly show the last one that we sent here.
Great. Yeah.
Great.
That was the last one.
Yes, right. And this is the geolocation platform.
There's a one. No, the number is wrong. 59998. 99077. You have some more. Delete it because you are not going to see it.
Okay.
598 99 99077 937.
That one, right?
That's right.
Okay.
Okay, so there you go. There you have the 3 tests, or 3, right? Maybe 2 of them fell incredibly in the same spot.
Yes.
If you can get a little bit nearer.
Okay.
Okay, so there we have the tests, the last 2 tests with the details of the requesting number, the USSD requester, and the latitude and longitude and other parameters like the E-UTRAN or LTE cell ID, okay, and the date. And as you can see, the date is right now, okay. Okay, so that's it. Thank you very much, Alan, and the TADHack community. Thank you very much, Emmanuel, Berman, and Kenny. And hope you see you soon on TAD Summit for EMEA and Americas. And thank you also, and great job, TELNYX, on your SMS API and all of your products. And we found it excellent. The documentation, as Emmanuel said, was very insightful and was very easy to use, the API. And the mashup turned out to be great. Thank you very much, and goodbye.